Hi, welcome to this Security Summit session in May 2021. And we're going to revisit a topic that we've seen a couple of times here around the Glamorous Toolkit, which is a really spectacular piece of technology that Tudor and a company that he works for has been developing. And we're going to try to approach it now from a point of view of threat modeling. And because I feel that the Glamorous Toolkit is actually a toolkit, right? To analyze and to understand. And there's a lot of other stuff that he does, of course. But one of the things he does really well is provides a really great framework and a great environment to create visualization and understand what's going on. And when we look at threat modeling and we look at how a lot of threat models are created, is they all tend to start with data flow diagrams. They start with how does the system work? How does it set up? How is everything done? And I think the Glamorous Toolkit can provide a lot of tools, right? And a lot of visualizations that will help that process of understanding how a particular app works and how it behaves, so everything is connected, including some cloud connectors that I know that has also been added. I think that there's several parts of this. I think today we could just explore a bit some of the more visualizations and some of the use cases of the toolkit, and because I feel there's other areas that maybe we can explore in other sessions next month and following on, which is how do we integrate this in a more CI pipeline, or how the teams can create this proactively. But let's start first with using the Glamorous Toolkit to understand how an application works and visualizing how it works. Which to just maybe quick introduction to you, and then dive us through what the toolkit can do at that level.
Thank you very much for having me. Glad to be back. So indeed, yes, we're building Glamorous Toolkit. Glamorous Toolkit is a moldable development environment. It enables this practice that we call moldable development, and that's the idea that everything in a software system is just data, and data doesn't have a specific shape. But we need a shape to reason about anything. And the tools are those that actually give us that translation that we require in order to reason about our systems. And so that's the primary motivation behind Glamorous Toolkit. Now, Glamorous Toolkit is a reasonably extensive environment. It is working, for example, for analysis purposes. It is working with multiple other languages. So it's interesting. Like this subject of threat modeling is interesting because whenever we work with people that are concerned with security, what we see there is that there are at least two ways to look at to approach security. Like you can think of it as you just come from the outside and then just try to poke in from whatever you see from the outside. On the other hand, right, if you look at it from the inside out, right, so you don't look at it from the outside, you look to the inside, then you have all sorts of knowledge about the ways you can actually poke at it from the outside. So just looking at it from the outside is already interesting, and definitely people should do that if there is no other knowledge. But in most cases, you already have lots of knowledge about the inside of your system, or at least you have access to the inside of your system. So it should follow there that we should be able to utilize that knowledge to then leverage to the figure out what are the potential attacks through it. So okay, so from this perspective, there are a couple of things that from which the Glamorous Toolkit helps with, and one of them is based on this idea that systems, they look very similar, but at the end of the day, they are actually quite specific. So they have very interesting peculiarities that only exist in that system, or maybe a few others. But and if you don't know about those, then you're blinded basically by if you're just looking at it too generically. So yeah, like you said, we have these option here in Glamorous Toolkit to build all sorts of interesting analysis. But the key element there is still that we start from a specific question and not from an analysis, right? So it's the flow is upside down. We don't start from just, oh, let's click, 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 and then do something. We start from the kind of things that we actually want to see. So it's like it's an intelligent conversation, not just a poking around situation. So when you go to Glamorous Toolkit here, you're met with a couple of slideshows. So one of them is looking at, so just introduces this idea of how, for example, how would we, analyze some Java, a system that is written in Java. This is like a slideshow over here. So so we have a situation here, and it's a very basic situation. It's one of the simplest problems. It's not related necessarily to security, although it can, but it's one of the simplest evolutionary problems, one of the simplest architectural problems you can think of. And that is, you take some classes in Java, and then let's say that you have a few of them are annotated with deprecated, and you want to find out which are the classes that are annotated with deprecated you can remove, and those that you cannot remove, what do you do about them? So so here we are having this problem, and so when we work with people and coach them to adopt multiple development, we ask them, so how would you approach this problem? Because this is not a difficult problem to think of, and many people have encountered this problem. So, and in fact, you see this type of problem mentioned it's often mentioned in introductory courses to some like programming with Java. So it's supposed to be a highly well-known, and also it should be a highly optimized type of problem. So what we have here is, and then when we ask people, how do you reason about this problem? And then people describe the analysis that you have to do, which is pretty much saying, find all the deprecated classes and find the deprecated classes that have clients. And then of those, right, that don't have clients, that are no longer used, you can remove those. And then of those that you can remove, then what do you do with them? So this is pretty much the kind of questions that you have to go through. And when we ask people, how would you go about solving these problems? They are doing it via clicking. And so they would decompose the analysis in terms of clicks. And then when you ask people, so how much time would you need for something like this? And immediately the estimation goes into hours, if not more. So, but then there's the other alternative. The alternative would say, well, let's look at our system as being a data or piece of data, and so like this, we can actually look at it as if it's a database. So that's what I have over here. So I just loaded a model of a system, and now I can go and browse that model. So I can see here, for example, I have all the classes, access to those, and these are the classes. And I can go there and I can see, okay, I can see source code, for example. This is a class, but I can see its source code. But then at the same time, I can maybe also see other kinds of visualizations like that. So now what this one gives me is something called a blueprint. It's a classic visualization. And it basically splits the class into multiple layers. And then what you're seeing inside of here are methods that are basically calling each other. And these at the end here, these are attributes that are being accessed. And so you can very quickly scan through things. If you, for example, just care about public interfaces, you can just look at those over here, right? And then if you click on one of those, that's going to be a method. And so a method will then also have source code, or I can do, you can quickly transform this visualization into a browser if it's needed. So, but this is still clicking around, right? It's still just us playing around with yeah, by clicking. But our problem was very, very specific. And that is, let's go and find all the classes that are being deprecated. But now, because this is a database, I can also write a qualified query. So, for example, here in the database, I not only have classes and methods and attributes and whatever. I also have knowledge about annotations. So here, for example, we have an annotation called deprecated, right? And if I click on that one, it will tell me, oh, look, it's actually being used in 284 places. So if I click on that, I can see, wow, this one is, for example, if I click on this, this is now a method that indeed is annotated with deprecated. But our problem, and the reason we picked this problem specifically because it has, if you look at this system, right, there are 284 places annotated with deprecated, but we just want to care about classes, let's say. So it so happens that in this system, there are just exactly 25 classes being annotated with deprecated, which means that there is like 90% noise. From the perspective of the problem that we're looking for, we have 90% noise, but we wouldn't know it until we go through it. Right? So if you just search for star deprecated star, you will find lots of noise. So that's a first level problem. So a different way to look at this, because now we have, we saw, entities and links through the entities, we can just as well write a query. So here, that's exactly what we're having here. So we find all the model classes, of which we select those that are annotated with deprecated. And so when I select that, I have my 25 classes. And so I can now click on that, for example, just to verify, look, this is a Java class, and indeed it's annotated with deprecated. And let's check another one. Yeah, it's the same public class and they'll be deprecated. So we have very quick, feedback between the query we had, and then boom, we're now in a browsing situation. And then of course, the reason I'm interested in these classes, I want to find out which of these are still being used. So we can maybe start with those that are still being used. So 14 of them are not used. And then those that still have some clients, so they're still being used, there are 11 of them. And then this is where things become interesting. But so one of the things that we see here is that all of a sudden, right, like we have eliminated a great deal of, we solved or we addressed half of our problem without actually reading any code, because it's not a code reading problem. But by not reading, actually we have, we don't lose information. We actually gain, we enrich our understanding of the system, and we haven't read anything. So that's an interesting thing. And so now, what do we do next? And this is where it becomes interesting, because we can go on and do some more queries. We can start measuring, we can do some more queries and see how are they being used, from which packages are being used, and so on. So all of those things are possible. But then sometimes we just, you have other kinds of tools, and the other kinds of tools that are around are those that that you can use visualizations as a way to augment, right? So if you have a multidimensional problem, then very often visualization is a nice way to put views together so that you can navigate through it, through the problem. So that's exactly what we have here. In this situation, we want to take all of these classes, deprecated classes that are still being used, and we also want to put their client types in a scene, and then we want to connect all the client provider relationships and then lay them out to the four space layout. And if I do that, then all of a sudden this is what I see. So these are now over here. We can see that if a class is annotated with deprecated, we're going to color it red. Otherwise, we're going to color it gray. So now I have here deprecated classes over here, right? And then we have these three classes or four classes that are connected to it. So this is possibly more difficult to, it's more difficult to to remove, then, for example, something like this one, which would just require us to investigate this piece here in order to potentially affect two classes.
So Tudor, just a question from Brandon. And Brandon,
Yes,
by the way, feel free if you want to just, put on your microphone, right, and connect, right? So the question is, does Glamorous Toolkit support multiple languages other than Java? For example, if I have a large application with JavaScript, Jelly, Java, Python, etc.
Yeah, it does. Yeah, so we are already.
And Tudor, sorry to interrupt. Thanks, Dennis. Yeah, I could even give you a greater idea of what I'm talking about. So how large the application could be, say, we're talking in the number of millions of lines of code, right? So my concern would be, the memory required, right, to actually load, such a large application, and then you have the multiple languages, and even to the extent where I work at a large company, right, we have custom, like our own language.
Yes.
So I'll tell you, I work at ServiceNow, and we have this language called Glide, right? Which you're not going to see it outside of ServiceNow.
Yes.
So I'm just curious on how Glamorous Toolkit would handle that.
Yeah, it's very cool questions. So first question is, does it handle other languages? Yes, it handles a bunch of languages. But that's the interesting thing that you're pointing out, is what happens when you have this funky language that nobody ever heard of. And that's exactly it, right? And in fact, and I just want to, because like up to now here is a generic problem that you can have this problem in any Java system. And so it looks like, oh, okay, so you can do something with Java annotation or Java calls and whatever, which is already interesting. And this analysis, indeed, if I look at it here, already I can think of it in terms of, I can apply it exactly as it is on any other Java system, which is exactly why it's not particularly interesting. Because the interesting thing always comes from context. So for example, like, if you go back to security, if security would be, if context wouldn't play much of a role, then we could just have a button and, that would tell us if our application is secure. But things are not so easy because exactly because context is important. So the question is, how do you take that context and then you map it onto the situation you're having here? So the debate, this thing here is, let's say that that you have a UI and non-UI. I'm not going to write this one here, but basically it's the same. It's the same code, but now we have added a little bit of here in the border. I'm getting to it.
Yeah, but I think an important point is that you can use the Glamorous Toolkit to add support to a new language.
Yes,
to the point
I'm getting
where
to
you
it.
understand it. You get to it, right?
Yeah.
But that's almost the foundation. The foundation is that what I like about this, right, is that in fact, I built something similar called the O2 platform, right? But it didn't become as evolved as this because I guess I didn't evolve it as much. But I got to the point where I would be able to look at any framework and know that I was hours or days away from having a whole level of visibility and tools that I could analyze it. And I think the Glamorous Toolkit gives you that, right? Like you can spend a bit of time saying, okay, here's a new language, here's a new structure, here's a new framework built on top of a language. And almost the first step is make sure that you have the ASTs and you have almost like the meat to be able to do this kind of analysis. So then you go into context, which is when you get the next extra level.
Yeah. So here is exactly. So let's get back to that one just in a second. So here what we've done is we took this generic little analysis, which can, again, as I said, can apply it on any other system. But if this picture over here gives me an idea of costs, it said, well, okay, this one is probably more expensive to remove than one of these, for example, because there's just less links to it, to this one. But it still doesn't tell me what is value. And value has nothing, like it's a different variable from cost. Value is always contextual. But now, so here what I've done is, let's say that I know that there's a UI and then I know that there's a non-UI in my little system over here. So now if I just map that knowledge onto my visualization, all of a sudden I can start to have a more qualitative way to investigate this. And that's the key, right? And then the difference between this generic thing out of the box thing that you can click on and this thing that actually can be anchored in the context is you're just it's very close by, right? It's just exactly treated exactly in the same way. And so this is why we don't just add, code or programming to the environment. We made the environment be programmable from inside out. And so this here, we're just looking at the surface of it, but this principle exists throughout the whole environment. And it doesn't matter what data I have in front of me. I'm going to apply exactly this principle to it. So, going to the question of what kind of analysis, for example, here people saying, okay, you have JavaScript over here. So this is a JavaScript system. I can, for example, look at it like that. And I can see I have here some data, some source code. So I can also take a look at those. And these are now JavaScript files that I can look at. And so, you were talking about the AST. I can also just quickly take these ones and I can say, because I already have a JavaScript parser around, I can simply tell it to this file that I'm just looking at. I can just say, parse the contents of this file. And what do I get? Well, I get an abstract syntax tree now. And so now this is the data that I'm actually looking at. So I don't have yet the connected model. I have just the abstract syntax tree of JavaScript, of a JavaScript file, and I can go and look at it here. So now I have just a tree data structure that I can go and query for, which is already quite interesting. Now, of course, what's interesting about this application is that it's actually it's implemented in React Native, which is that's not interesting in itself, except that React Native is not really JavaScript. It has JavaScript syntax, but on top of it, it has these funky constructs that if you don't know about, you're going to miss pretty much most of the picture. So, so here is, right, if I have this, like in this case, I have the components, the React components. We have a little logic here that extracts that part. And then if I look at the component like that, it's something like this, right? It's a specific construct that you need to know that the library comes with in order to, and so the tool needs to know about that construct so that it can extract the logical components from it. And of course, now once you have these components, you can start, for example, looking at something like this. Now you have here and the dependencies, so I can click on that. For example, this is render button, and then I can see that it has a relationship over here to button and so on. So, and this is how that's another piece of it. Whenever we are approaching a system, we start from whatever information we know about, and then we start piling, or layer by layer, we add more understanding, and we enrich the tool with the more understanding we have about the context, the more we can enrich the tool, and the more we have access to the next level of context, and so on. So you're basically crawling your way through the knowledge associated with the code. But you always start from having some idea, some intent, and then you're going to build a tool that will validate or invalidate that intent, or that will at least allow you to browse some of it further. And then some of these can take the form of queries, some of these can take the form of visualizations. So it kind of goes like this. Now, there was one other question here, is that what do you do when you have like some new languages? So that is interesting, because that's another, a parser is just another tool that you will need to have. And so here is, I was just using the JavaScript parser over there. So I can see, okay, look here. There are a couple of these languages already out of the box. supported, like Clojure, C++, C Sharp, I don't know, even Delphi and Elixir and Java and JSON, Python, and maybe a couple of others. But more interesting is that you can build those yourself. And of course, like, wow, building a parser is such a scary thing. And yes, it is scary unless you have tools, because it's just another problem of building something, building a little analysis tool. And that's pretty much what we start from. So here, for example, this is how the if statement is being defined. And you're not left there just with editors. You're always the whole experience of working and building analysis we're trying as much as possible to add as much context and feedback. So for example, here's how this whole thing is being created. And so this becomes quite an interesting, and by the way, this isn't a live editor over here. So this is actually a very interesting way to analyze or to build these kinds of parsers. And if you want to, if I take this statement and I say I want to test it, I'm going to take this one over here and I'm going to say, okay, x equals 42. Let's say if it's return maybe true, right? Oh, look, it works. So, and I can also go here and see which parts of the grammar I matched, right? So this is, again, like very useful to just test parsers like that and build them reasonably quickly. Now, of course, building a parser for language is not a trivial thing. And if you can reuse those language parsers, by all means, you should, right? But then now you have your special language. And what do you do then, right? So if you do not have, if your toolkit is not, or if around you, it's not possible to create or not easily possible to create these parsers or to reverse engineer the language sometimes. So we have cases where we work with companies for which, and with systems for which they don't know the language. They can't give us the grammar, or the description of the language is actually wrong sometimes. This happens more often than we thought. And so in that situation, you actually have to reverse engineer the language itself before you can actually reverse engineer the system. And yeah, we do that. It's, as I said, like it happens a little more often than we would have hoped for. But you have to be prepared for that, because that is an engineering reality. And we think that without this ability in-house, there's a certain level of exposure that you have to problems that you're basically blindsided, because you're not able to reason about the space that you should be reasoning about. Now, but what's interesting here is that it's not even just languages. Because, like if you say, oh, I have this new language, or, like we were working with a couple of mainframe languages that were homegrown, built on top of COBOL, for which there was no, like the description was no longer accurate. So only the interpreter would know what happens there. So, but sometimes the problem is much less conspicuous, right? It's not, you'd say, well, it's just generic system. Like people say, it's a Java system, right? So let's just take a simple problem like that. So if I look at, for example, here, I have another one of those that just a generic application that we saw online. We don't know anything about it, but what is interesting about that is that you'd say, well, this is implemented in Java, except it's implemented in Java. The backend is implemented in Spring. So now, if we look at this one now, right, and if you look at if you're going to take the classes and you're going to look at those classes, and you look like this, then you have some idea about what's going on here. You can find some of the logic like this. But if you're not going to be able to, if you're not browsing the annotations, you're actually blinded quite a bit, because now there's a significant amount of logic that is being injected into your system through these annotations. So here we have, like for this kind of default, Java lang override. But then if you look at some more interesting ones, such as, like request mapping, these are quite interesting because you see here I have 287 of them. So what are those, right? If I go and investigate that, these are now, this is a class, which is a, it's request. So it basically says there's going to be this URL exposed for the API, so /subject. And if I'm going to look at, and then there's going to be a /subject/list all that is another URL. That is going to be exposed. Now, why is this interesting? Now, let's go back to the context of this session, where we're saying, okay, threat modeling. Well, okay, so one of the ways, right? You want to find out the ways you can get in, right? So, what are the ways you can get in? So, one way, one obvious way, is to just say, well, what is the API? And so, of course, now you can say, well, okay, let's look at the documentation. That's one. But then, if I look at inside, if I look in my system, I should be able to find out what my API is. Now, of course, if you're lucky and maybe you have some Swagger documentation, you can maybe generate from there. But what if it's not complete, right? Because you should still be able to go in and reason about that. So let's actually do that.
Hey, Tudor,
So,
quick,
yeah.
sorry to interrupt. Quick question on, oh, they're not line numbered, but API, that annotation API, you have the blocks there in blue. What does that mean? Description equals.
Oh, this is actually this is a an Asian language being used here, and it's just not displayed.
Okay, got it. Different.
It's just just characters. Okay, so here I have a class, right? And there's like I did before. I want to say, give me is annotated with deprecated, for example. I can say self is annotated with request mapping. And if I print that, so well, okay, yeah, that's true. Yeah, it is annotated with request mapping. So I can basically start to say, oh, that's interesting. I can query that. And now, once I have this, the other interesting part of it is that I can also enhance once I know a library, and once I know that my system is relying on certain idioms. It could be a public library like this one, or it could be a homegrown library, or maybe it's a combination of libraries, or like you were saying before, Brandon, it could be a combination of languages that basically rely on just communicating across with each other, usually through some sort of conventions. So once you have that, what you want is you would want your environment, or the knowledge base about your system to be enriched with this specific understanding. So here I'm writing just the generic thing. So let's actually do some more over here. I can actually say, give me all the annotation instances, I think it is. So if I'm executing that one, I'm going to get 3 of them. So let's see, 1, 2, 3. I can see those here. These are the annotations that I get. And then maybe from here I can say, well, okay, actually, let's see if I can detect from here if each of them, the name of it is request mapping. And if it's found, then the annotation, I want to just return true. So if I execute that, return true. Oh, no. Oh, yeah. Well, if I do this, it does, yeah, okay, it's not found. Why is it not found? Request mapping. Should it be like this? No. Let's see. If this one over here, it should have a self name. Yes, the self name is a little bit more complicated than I thought it is. Okay, so I'm not going to show this one, but basically I can go and query this. But then there's an alternative to this. So if I already have these kind of abilities, what I would do now is, so here I'm looking at an object that represents the Java class. And what I want, this kind of, for example, this annotation instances, this is now a method or a message that this object can understand, which is implemented as a method. So now if I want to go in and enrich my model, I can go in here. So now I'm looking at the implementation of the model that I'm actually querying, of the database that I'm actually querying now. So I can look at here at various methods that I already have. So what's interesting is that I have, for example, here I can see a method which is called Spring Root Path Value. So let's see what happens if I do that. Spring Root Path Value. So this method exists in this class, in the Phonics class, and now I want to go back to my original class, the Java one, and I want to say, give me the Spring Root path value, and boom, I get /subject. So it extracted for me this little this one over here. So armed with this, I can actually go and do I can actually go and do here all the, I can go and find, in this case, all the classes. So I'm going to say all from the model, I'm going to get all the classes. And I'm going to say, I want to now find, maybe not classes, but I'm going to do it the same thing for methods. I'm going to say, give me all those that are Spring Root. And if I execute that, I'm going to have 242 of them. And so, so from here, I can then also say, I can say, well, actually give me, from each of these methods, give me the Spring Root path value. If I execute that, I'm getting this. So I'm getting basically all the paths that can that have a method associated with it, as defined by
Tudor,
these annotations. Yes.
Sorry to interrupt, but this is super cool, right? Like, you're giving us different examples on how to query the model and just how to query. Can I be a little bit selfish and just kind of cut to the chase and say, hey, can we like complete the loop here on the threat modeling and say, all right, we do a query, we identify an object, we see maybe even a method that's implemented, right? And then can we introduce metadata and enrich that particular query with a threat, and then match that threat with a control? Is it possible?
Yeah. Well, is it possible? Yes. Is it something that we like we have done before? No. Is it something that the other people have played with? Yes. And that's the thing, right? But the key element here is that there's knowledge that says, okay, once you know what is an entry point, then there's a reasonable amount of literature saying how would you like to attack it, right? Once you know that.
Yeah, but I will say this, Tudor. The problem that I have, right, and the problem that a lot of products in this category, threat modeling, so I could take Arius Risk as an example, since they're kind of the leader in the space at this point for this type of context, that it's, for me as a threat modeler, there are just so many things to remember, right? And I could remember some of them, but I can't remember all of them. So they would be really helpful to have actually rules triggered that I, in the past, right, set as my metadata, and I want to be able to query that, because otherwise I'm kind of left at, do I make my own app and then I create a library of all my threats and controls, and then the relationship with the model on how to map those up?
So Brendan, like where I think the opportunity here lies is that with something like the Glamorous Toolkit, right, what you're describing is possible, right? The thing about it is that without this kind of flexibility, very quickly, and I love the question you're asking, because that's exactly how I approach these things, right? Very quickly you enter the realm of science fiction, right? Because very quickly you try to do things that some of the tools or some of the capabilities are like, they're not even on the same planet, right? Like, you can't even do sometimes basic manipulations, might as well, the kind of things you're doing, right? Because when I look at this, right, it kind of reminds me of the days I was building static analysis engine and trying to consume static analysis data, right? And think about how primitive the UIs and the capabilities were to build rules, right? I think that what we should be doing as a community now is saying, look, this is a great foundation. We now need to build, in a way, those almost domain-specific meta-analysis, those domain-specific visualizations. Like, I'll give you an example. Like, I did a bunch of work on Spring Framework, where, in fact, I did a mapping, right? Where I was showing the auto-binding, capabilities of the Spring Framework. If you know that, the whole mass assignment vulnerability, right?
Now, right. It's very complicated, like all the annotations in Spring, exactly, like right? How so, you could spend a day like just looking at one line, right?
Exactly, yeah. Right. So I built a tool to do that, right? So in a way, but I feel that what I didn't have was some of the things that exist here, right? And I feel that that's a piece of work that almost we as a community should be working on, so that when, in a way, the developer or the more, not even the less experienced, but the one when you're in engagement, you don't want to be building those capabilities, right? You want to say, okay, I have an application, it has a Spring Framework, it has this. It's almost like you want to go to your toolkit and going, cool, now let me wire up the Spring Framework modeler, but then knowing that every app has a flavor of it. So this is the thing that I remember used to argue when I was talking about the static analysis crowd, of saying, you need to understand that even when you support the Spring Framework, even when you support a particular flavor of it, the application that you're going to be looking in front of you is going to have different things. It's going to have different contexts. It's going to be doing different stuff. So I feel that there's always a bit of work that needs to be done. I think the question is how much of that work needs to be done in a way by maybe specialists or one-off, and then how much value do you get, right, once you get that in place. And okay. my view at the moment is that we want to make sure that, like, and I think that, and I will argue these days that, because I also control some of the development teams, I think the developer teams need to make this easier, right? Like it has to be a two-way conversation, if possible, where almost you need to use your development resources to help to create visibility into how the app works, so that when you're asking questions, right, you're very effective in those questions, and you can write tests on top of those questions.
Right. So how do we extend this, Tudor? Like, how can I create a library? Like, for instance, if you do know Arius risk, right? Because I think they have, at least at a high level, the architecture and engineering down to a point where it's practical. And what they have are rules. It's a Java thing, right? It's well documented. So is there a way that I can introduce some kind of concept like this, or rules, and maybe even create a plugin to apply some of these libraries of threats and controls?
Sure. As I said, this is a program. The Glamorous Toolkit is a programmable platform, which means it's like there is no. It's not like, oh, here's a little script with which you're gonna do. But we give you some leverage for some customization. Everything is programmable. The complete stack is programmable, including the graphical things and so on. Which means
go a level above, right? I think.
Which means that you have access to any point. Now it's very tempting to say, I'm gonna use this library, and they're gonna we're gonna delegate these the basic parts. We're gonna delegate it to the people that are doing the generic parts. But what they're gonna do about your system, which only like this specific language that only exists in that company, who are you gonna delegate it to? You can't, right? So
right. Well, I want to develop a tool where I could delegate it to other people to use the tool.
But that's the point, right? The point is that there's always going to be, and that's what we have found, and this is what's interesting in Glamorous Toolkit, or at least in our opinion is interesting in our Glamorous Toolkit. This is not a security tool. This is a fundamental perspective on the nature of software development. Everything in software development requires a perspective, not just static analysis, not just security. Everything in software development requires some views, and we are practicing it since years. So now, and like you were saying here, and like also like Dinis is saying, this is a platform. Now it's up to different communities to start building knowledge on top of it and use it as a tool to drive whatever knowledge you want to consolidate. But yes, and then there's the other point. Like you were also, Dinis, you were talking about this relationship between your security and development. This is definitely should, like, up to now, right? We were just playing a little bit with this idea that, I'm going to analyze what you're doing. But that's such a rudimentary way of, like, you need a feedback loop. So like if I'm going to play with you and I collaborate with you, you want to learn from me. But you know what's interesting is that if I can give you a picture of a problem, you're going to relate to that problem in a much shorter amount of time. Usually we find that we can compress communication to minutes. Like imagine like the way we document bugs, the way we document problems that we find about somebody else's. We literally create a little tiny analysis that just captures what we think in the screen, put it as a picture, and that's pretty much the whole description of it. And people understand it in seconds or minutes, rather than a very lengthy text and lots of things happening around there. And then you can go a step further because you can say, well, when I have a long, maybe I have a log of possible issues, and then maybe the threat is actually, or the security problem is actually seeable in that log. I'm going to build a little tool that will analyze that log, and it will tell me where the problem is, and it will document it. Like you were saying, as soon as I know about a problem, I want to delegate it to a tool, except that pretty much not all, like we've done it with tests. So for the longest time now, I mean, not the longest time, it's just for a couple of decades now, people are writing, they say, oh, this is a problem, write a test. So document the problem and you delegate it. Except that there are all sorts of interesting problems that are not decomposable as tests. And so...
Okay, Tudor, but this is where I think we spoke about on the previous sessions, right? Going back to your feedback loop, right? I'm pretty convinced that the Glamorous Toolkit it's a great platform, right? It's a great way to develop, to visualize. I think what we need to now figure out is how to make it usable in the CI pipeline, right? Is how to take, for example, one scenario and say, I can now connect the dots in this one scenario in a way that I get that information, I get that refactoring, right? And I get that deployment so that I can say, I'm looking for this. And look, in the beginning of this, right, it's okay to start with a scenario that we know. Like we don't need to go hunting for unknown unknowns, right? Like there's cases where I could say, look, I want to find secrets. I want to find this pattern. I want to find like the attack surface, like something as simple as give me every single URL that is possible on a web application, right? Those are not simple answers sometimes, but the answer should be simple, right? Like the answer should actually be, right, a list of URLs that you can then feed to another tool, for example, right?
Yeah.
Or something that you can then feed to Iris Risk, for example. Like how do we integrate this with Iris Risk, which I know, I think is a great tool, right? And say, okay, cool. Can I, Iris Risk will tend to represent wishful thinking, right? I.e. people describe what they think they have, right? This will allow me to connect the dots and say, actually, this is what exists in reality, right?
Right. Yeah, no, I agree. With the problem with a lot of the threat modeling tools is you have this template, you have this library, right, of threats and controls, and it's like the first time you use it, it's like you bring home a puppy, right, and it's just peeing everywhere. So you got to have to train it and then kind of scope down a lot of those threats and controls that it creates just on its own, and being able to get this kind of feedback and interrogate the really the objects and establish some kind of call graph or other ways to do this, right, to traverse if you do have the code. Really cool, and kind of fits outside the scope of these products.
And so for example,
I think for adoption, right, for a lot of the stuff that for the Glamorous Toolkit to be adopted, I think we need to find ways that the tools start to use it sometimes even without knowing they're using it, right? It's kind of like we need to get to the point where you have that specific rules, that specific toolkit, that specific sort of model that you talk about. And it's when they then ask the question, whoa, how was that done? Or actually, sorry, I want to throw a curveball here, but like Brenda was saying, can I just add some metadata here? Can you connect this with that stuff over there? I think that's when the power of the toolkit comes along, because you go, oh, cool. Basically how deep the rabbit hole can go, right? How deep you want to go in your framework, but it's kind of like a wordly map is, right? Like if you think about it, like you want to be commoditizing each of the layers, right? Like, the Glamorous Toolkit commoditize a lot of the very complex modeling stuff, right? But now you need to build stuff on top of it that you also commoditize, the Spring module, and then you build stuff on top of it, which maybe is an extra thing, right? And then you keep going up until it's super easy to use, but you have all the power and the need when you want to make a change, which what I think is really exciting, on this. And I feel the thread modeling, it's a good place to start, because thread modeling has a lot of problems today, is scaling. There's tons of people trying to do it, but there's a lot of, still a lot of art, right? And we're not really capturing a lot of the materials. And my problem with it is that I want to invest on thread model, but I want to leave almost an infrastructure in place so that the next code change, doesn't require a lot of heavy lifting. The next, scales, right? But that scaffolding, that infrastructure has to almost now be invisible to the teams, right? Like how it was built cannot be, it's almost like the developer or the architect should not have to now understand how the hell that diagram is now updating in real time, right? Because I just added this new code here and suddenly, boom, there's a box here, right? That I think is very important.
Yeah. Got a question here. So, Tudor, hi. First of all, beautiful system, like really glamorous. The thing that I'm having a bit of a difficulty here is actually two things. First of all, you showed us something that's based on an existing code base. So when I look at traditional thread modeling, that already gives me a pause in thinking that perhaps this is awesome to understand. I don't know, I just came up on legacy code and I have to understand what the thing is. And this would help me figure out what the system is so that I can model it. The second question that I have is, this thing looks really, really, really complex. What is the learning curve to get somebody working with this thing and getting results out of it? Because the way that I'm thinking right now, if I put this in the hands of a developer, I'm going to find myself flying through the window very, very quick.
One thing I will say, though, I would never give this to a developer, in terms of applying the threat model, right? This is, the use case
that's where
here,
things are going.
Yeah,
right?
So, but it's like, anyway, we could have a debate on that.
So let's see.
You're just giving me a huge bottleneck here.
Yeah, guys. So I'm gonna have to look. You can stay in this session. It's great. Like I really realize that I double booked myself. I really want to continue here, but continue. I need to do another session at the summit. But the only thing I would say is something that was told to me when I was showing similar systems, is that this is very simple, right? For somebody who's asking these questions, right? Like when I look at this is simple because I can see the complexity that I would have to do to arrive at here. Now, it doesn't mean that you can give this, for example, to the end user, but which is what I think the sweet spot is, right? I think the sweet spot for this today is the tool builders, is the security engineers, is the extra developers who are trying to answer these questions and they are stuck. They're stuck because they're playing with matchsticks and rocks and this is a car, right? So I think that's the sweet spot. But this and this is where the worldly maps is interesting, because we need to get to the point where we create something that, yeah, is usable by a developer, right? Is usable by somebody who doesn't even see the Glamorous Toolkit initially.
Yeah,
right?
Yeah, absolutely.
Cool. Well, I'll leave you guys. No. I'll continue, but I'll watch the recording, right? And let's actually continue next month, because I think this is really cool.
Let's do that.
Absolutely. All right, continue, please.
So,
keep going as much as you want.
So back to your question. We have these, like there are two roles in multiple development. One of it is the stakeholder is the one that asks the question. And then there is the facilitator, which is the one that actually knows how to build the tool. Now, these are two different roles. And then of course, like if you have a team, you don't want to expose necessarily, not everybody will become facilitators. Just like, for example, not everybody is an ops in a DevOps team, right? But everybody knows how to create, everybody knows how to say what is interesting, what is needed from a DevOps perspective. They can formulate the problems but they might not necessarily know how to put it in place because that's a specific skill. So not everybody, what I showed you here was how do you navigate, like how are you going to build this thing? And of course, like there's a cost learning curves, as you were saying. In our experience, it takes about a month, it takes about a week to learn how to learn, 5 days, 2 to 5 days, and about a month to get proficient, or reasonably proficient with the system. So, but now this is, you would say, well, that's like an investment, a very large investment, but then you can start to apply it in all sorts of different situations, and then it becomes actually much cheaper. We usually see advertised, like we usually see the cost advertised within a month or so. Because what we're actually replacing is this problem, is the problem that most of the energy being spent in engineering today is actually spent on developers reading code. But reading happens to be the most manual possible way to extract information out of a system. And anything you can do to optimize that one. And the interesting thing is that the budget is already allocated, so you don't have to ask for budget. You just want to say, how do I repurpose this budget that is already there? And so the reason why developers read code is because they want to make a decision. So we look at software engineering as being primarily a decision-making activity rather than a construction activity. And then once you start looking at it like that, then you want to optimize for it. And then all sorts of economics. The economic question is absolutely relevant, but you have to frame it in the actual problem context. And the problem context today is that 50% or more of the time, developers read code, which also happens to be the single largest expense we're having. Now, how many times do you hear developers talk about how they read code? Right? It's almost never how they read code, not about the code that they read, but about how they do the reading. That's not a subject conversation, is it? Now, what's interesting...
It's not a question that I hear a lot, I have to tell you.
It is not, right? But think about this, right? This is what occupies the single largest, this is what is responsible for the single largest expense in development. Single largest expense. So if you're worried about economics, then go worry.
How do we know that?
Oh, there's plenty of research going back all the way to 1979. There was a book on that, and actually it goes even further back into the 60s. It's still there.
I didn't
and
know.
It's not. But you can go and ask developers, and I've done that. I've asked more than 3,000, 4,000 by now. Developers, do you agree that you spend 50% or more of your time reading code? The vast majority of them, they will say yes. If so, then you can just ask the next question. So when was the last time you talked about how you read code? And it's going to be an awkward question because it's not a subject. No, it's a strange thing to ask, but it's still what occupies the largest cost. If you're not talking about something, it is not explicit. If it's not explicit, it has never been optimized. It's the single largest expense there is, and has never been optimized. That's what we are optimizing. And this Glamorous Toolkit is not just something for security. It's not just something for static analysis. It's a whole idea of how software development could look like. We just looked here at a certain angle of it, but the promise is broader than that. So it's that's the essence. Now, of course, once I can write something as a query, right? If I can, what you saw me there doing was I was the facilitator. I was this one, and getting some sort of a question. I was this one, and now I give this information to somebody that wants to know, that can go and interpret it. But the interesting thing here is you have to ask yourself, could you follow what I was showing? Because if you could, right, and it looks like you did. If you could follow what I was showing, it meant that it was actually not that foreign. Either was I was an extraordinary presenter, or I was actually not showing anything that out of the ordinary. And you know what I like to, it's actually not that. In fact, most systems, most development is really doing just that. Taking some data, modeling it, querying it, manipulating it, transforming it, maybe visualizing for some people, some other people to make decisions about. That's pretty much what most software is doing. We just can turn those skills and start solving our own problems. So, but now once I can do that, right? Once I can write these kinds of queries, I can also transform those into tests, like what Dinis was saying. And these tests, I'm now running them here inside. And so, for example, this is a yellow test, a yellow check that gives me some problems in the system, and I can look at how this thing is implemented. This is the query. It doesn't matter what the test says, but it's like you can think of it like an architectural test that is problematic. But then this exact execution can also be integrated into Jenkins, and then people can consume the output without actually knowing anything about, or without actually having to know anything about Glamorous. So
Tudor,
that was it.
I'm going to have.
Yeah, me too.
Are there good resources for us to get ramped up? You have a fantastic website. I was just curious if most of the resources are available at Glamorous Toolkit.
Most of the resources are available at Glamorous Toolkit. There are also newer series of YouTube videos that we're having there. You can find them from there. There are also documentation or articles that are being written about it. But Glamorous Toolkit itself comes also with documentation. So if you go and, all of these demos that I showed you are actually available right from the start. So you can just go and go through the different materials that we have over here. So you can learn like that.
Cool. Thank you.
Okay. Well, thank you very much. And see you next time.
Bye. Thanks.
Bye.